This is the screencast for section 6.3, example 4, solving for the unknown integral. So as you can see, this integral, the integral of e to the x cosine of x dx, is definitely a product of two functions of x, but e to the x, if you take its derivative, has a repetitive pattern. It's just e to the x, and then take the derivative, it's e to the x, and then take the derivative, it's e to the x. Nothing is going to diminish to make our integral easy, the integral part of integration by parts easier. Now, cosine of x is the same thing. That is a cyclical derivative, so neither one of these is going to, neither one of these as u is going to make our situation any easier. So, in this situation, I am going to pick my u to be cosine of x and my dv to be e to the x. Mostly I'm going to pick u to be cosine of the x just because it changes a little bit, I guess. It really wouldn't matter either way. So here we go. I'm going to pick u cosine of x dv e to the x, which means du is negative sine of x dx and v is just e to the x. So now I'm going to do integration by parts. U times v minus the antiderivative of v times du. Now, this isn't going to get us anywhere, but remember, we're solving for what the antiderivative of e to the x cosine of x dx is. So I'm going to put that after my equal sign to then show that this antidifferentiation by parts is supposed to equal this antiderivative. Alright, so I'm going to work with the left side of this equation. I'm going to keep going because, as you can see, even if I simplify a little bit, put that negative sign outside, I still have the antiderivative of e to the x sine of x, a similar situation that I was dealing with before. So I'm going to do antidifferentiation by parts again, making u this time sine of x, related to what I made u before. And then dv is going to be e to the x, take the derivative of u, and take the antiderivative of v. Now I have cosine of x e to the x from the previous antidifferentiation by parts, plus, now here's my new antidifferentiation by parts, u times v minus the antiderivative of v times du. And of course, the moral of the story here is this whole expression I'm building equals the antiderivative of e to the x cosine of x dx, what I'm supposed to be solving for. Alright, so now I have an expression with three terms that equals the antiderivative of e to the x cosine of x dx. Now, as you see on the left side here, I have another expression that has the antiderivative of e to the x cosine of x dx. There is a like term that I can combine, so I'm going to add the antiderivative of e to the x cosine of x to both sides, which leaves me with part of the integration by parts expression equal to twice the antiderivative I'm trying to solve for. So now all I got to do is divide both sides by 2, and I've got my solution. The antiderivative of e to the x cosine of x dx equals 1/2 cosine of x e to the x plus 1/2 sine of x e to the x plus c. I know this is blowing your mind right now because we didn't actually really solve for anything. We didn't actually find an integral. We just did integration by parts twice, got a common term, added it to both sides, and then divided by 2. It's almost like we're cheating, but it's not. We did the antidifferentiation by parts twice in order to get that common term. That was essentially our goal. And of course, since we did antidifferentiation by parts partially twice, there still was calculus involved in this, and it was taking the antiderivative a couple of times, or 2 half times, I guess, again, to come up with this common term on both sides of the equal sign. The now try problem, number 17, says use parts and solve for the unknown integral. And they meant integration by parts. Okay, so e to the x, the antiderivative of e to the x sine of x dx. Very similar to the example. So, and I told you that it doesn't really matter what u or dv is in this cyclical situation where taking the derivative of e to the x or sine of x would not produce something a little bit easier to work with. So since in example 4 I made u cosine of x, I'm going to make u e to the x this time. And then that means dv is sine of x dx. And I did just realize that in the last several problems, I have not been putting the dx next to dv. That's very important when you're taking the antiderivative. So dx is definitely a part of dv, so you can take the antiderivative and find v. So du is e to the x dx, then v is negative cosine of x. So now I already know that this is going to be a situation where I'm going to have to do integration by parts and then solve for the equal sign, because I can see that e to the x and sine of x aren't going to diminish as I take the derivative. So I put the integral of e to the x sine of x dx equals, and now I'm going to do my integration by parts. So u times v minus the antiderivative of v times du, and then simplify a little bit. So I've got another situation where I have the antiderivative of a product of two functions of x. Both are cyclical derivatives. They're just going to keep going forever and ever and ever. So I'm going to do integration by parts again. This time I'm going to call u e to the x, similar to the previous time in this problem. And then dv is going to be cosine of x, again the related part of the product. Derivative of u then is e to the x dx, or du, and then v is sine of x. So the antiderivative of e to the x sine of x dx is what I had from my first integration by parts, plus now a new integration by parts using my new u, du, dv, and v. So u times v minus the antiderivative of v again times du. And again, we'll simplify, and I can see that I have a like term on the right side of the equal sign, as do I on the left side of the equal sign, the integral I'm trying to solve in the first place. So I'm going to combine like terms by adding the integral of e to the x sine of x dx, getting rid of it on this side. So now on the left side I have two antiderivatives of e to the x sine of x dx. Divide both sides by 2. And I get that the antiderivative of e to the x sine of x dx, my whole goal to solve for in the first place, is 1/2 e to the x sine of x minus 1/2 e to the x cosine of x, plus c, of course. And then, I don't know, depending on what form your answer is, you could factor out that 1/2 e to the x, which leaves you with sine of x cosine of x on the inside of the parentheses, and then still a plus c.